Today, Dr. Fridolin Ting would go to talk about linear approximation.
Hi darling, do you know how to find the value of e and pi? I have forgot to bring the calculator.
Hi darling, it seems that we can use linear approximation. Let Dr. Ting teach us how to do so.
We need to approximate a function f of x near x equal to x naught by a line. So what am I talking about? Well, suppose we have this function, which I'll highlight in yellow. Okay, so here's our function. Here, y equal to f of x. Now, suppose we want to calculate this actual value here. Say f at, for the moment, we'll say we want to calculate f at x naught plus change in x. So in fact, it's this point right here. Okay. So 9 times out of 10, we actually do not know f at x naught plus dx. Okay. So the input being x naught plus dx. We don't know the output f at x naught plus dx. So what we do is we choose an input close to x naught plus dx, where dx is assumed to be small. So like I was saying, we choose a x naught which is close to x naught plus dx. So dx is small, right? Dx is small. And what we do is we draw a line. Since we know the derivative, say at that x naught usually is a very easy number, and we usually know f at x naught, f at the input x naught. It's an easy number to calculate. Okay, so if we know that and we know the derivative, then what we can do is we can draw the tangent line, okay, which I'll color in the tangent line to the point, to the function at x naught. Okay, so this green line. And what you can see is that the green line is very close to the yellow function, the actual function value. So what we have is that we know that, so f at x naught is minus f at x naught is approximately equal to the derivative of f prime at x naught times the change in x. So in the graph here, change in x is equal to dx. Okay. So this is because you can write the derivative, right, as a limit. And of course, if you take out the limits, for small change in x is approximately equal to this. So in fact, the actual change in y here, which is what we want, is approximately equal to the differential change, which is dy. Okay, so in fact, the actual change, what we want, is approximately equal to the derivative of f at x naught, okay, times change in x. Okay. So just some notation here that df, the approximate change, is equal to f prime at x naught times change in x. Is called the differential of f at x naught. Okay. So to summarize, we say the linear approximation formula for the function f of x near x naught, we denote it by capital L of x. So this is, in fact, if you want, this green line is in fact our linear approximation. So our green line is in fact given by this formula, which I'll highlight in yellow. It's given by this formula. F at x naught plus f prime of x naught times x minus x naught. This actually is called a linear approximation f of x near x naught.
We will talk about 2 examples on how to use linear approximation to solve square root of 104 and cosine 40 degree.
First, figure out our function, which we need to approximate. Well, here, f of x is the square root function. Now, can you guess what do you think are x naught and change in x here in the formula for the linear approximation? So remember, change in x is there x minus x naught. Well, x naught is 100, right? And we want to approximate square root of 104, so x must be 104. And since x naught is 100, then change in x is just 4. So our linear approximation, right, at x naught equal to 100 is given by, oh sorry, there's no, right, it's given by f at x naught plus f prime of x naught times change in x, right, by our linear approximation. This is of course just change in x. This is of course just change in x. This is here. This is our change in x. So we have everything except for f prime of x naught. Well, what's f prime of x naught? Okay, let's do it in blue here. We know f prime by regular power rule is just 1 over 2, right? Square root of x. So we have everything basically. So this is basically equal to f at x naught, which is square root of 100, which we know, plus f prime x naught, which is 1 over 2 square root of 100, times change in x, which is 4. So in fact, this is just 10 plus 1 over 20 times 4, which is just 10.5. Okay. So what's our actual answer? So this is our linear approximation. Oh, sorry, it's 10.2. Not 10.4. So this is our approximation at the beach. Now, when we plug in square root of 104 in the calculator, what do we actually get? Well, I've put up the solutions in another part of the PowerPoint. In fact, using calculator is 10.198. So it's very close, right, to 10.2. So it's a good approximation. How do we approximate close to 40 without a calculator at the beach? Well, okay, we do the same thing. We use a linear approximation. So in this case, first we have our function. Here is of course cos x. And what about our x naught? Well, x naught, we choose something which we know the value of cos of, right? So in this case, it has to be 45 degrees. But remember, cos is, we use as inputs radians, right? So 45 degrees is actually pi over 4. Okay. And what's going to be our change in x? Change in x, remember, is our x minus x naught. So x is the one input we want to evaluate at cos. So in fact, this is 40 degrees, right? So 40 degrees is what? Is 2 pi So that's 360 degrees divided by 9. 360 divided by 9 is 40 degrees. So that's why 2 pi minus 9 is 40 degrees minus x naught, which is pi over 4. So in fact, this is going to be 2 pi. So we multiply, cross multiply, 8 pi over 9. 8 pi, sorry, minus 9 times pi over 36, which is minus pi over 36. Okay, so this is our change in x. Okay, so we have everything. We have our f of x. We have our x naught. And we have our change in x. Everything we need for the linear approximation. So let's the linear approximation of cos at 45 degrees is going to be f of x naught plus f prime of x naught times change in x. So we have, this is just pi over 4. So cos of pi over 4 plus, so the derivative of cos is minus sign, right? So we don't need to, this is minus sign. We don't need to do separate calculation. Add x now, which is pi over 4, times change in x, which is minus pi over 36. Okay, so this is just 1 over cos of pi over 4 is 1 over root 2. Minus sine of pi over 4 is minus 1 over root 2 times minus pi over 6, 36. So this is just equal to pi plus 1 over pi plus 36, sorry. Over square root 2 times 36. Okay. So in fact, that's the approximation to cos of 40 degrees. Okay, and I've done the full calculation again here if you want it in more nicer text. And the calculator, you can compare. So this is the figure you get. Of course, we use a calculator to do this, but the actual, when you plug it into the calculator, yeah, this is the calculator value here in red. And as you can see, they're both very close approximations.
Thank you, Dr. Ting, for today's class. If you are interested with the topic, please watch more online videos.